this real quick. Bless you. Only if you need them. I mean, I don't need it, but I would assume most of y'all probably need the arrows. So I need line paper to do this for y'all. Looks like most of the rest of them are lined up okay. Yeah. All right. All right. So cobalt. How many electrons are we working with?
27.
27. What's the first thing in the chart when you read it?
1s.
Next.
2s.
Next.
2p.
Next.
3s.
All right. So how many lines can we put above 1s?
1.
Above 2s?
1.
2p?
3.
And 3s.
1.
So if we stop and count to see how many we have so far, we have how many electrons here?
2, 4, 6, 8, 10, 12.
So we're not at 27, right? So back to the chart. What comes after 3s? How many lines above a p?
3.
Next.
4s.
Okay, what can go above an s?
1.
So we were at 12, so this would be,
14. 8.
so we're still not at 27, so what comes after 3s? 3d. So how many lines above a d?
5.
Okay, so that was 20. So this would be 22. So 30 will cover 27 electrons. So we don't need to go any further than 3D. All right, so where's the first electron going? All right, is 1s full?
No.
Nope. So where's the second electron need to go? It's got to go on 1s. Got to spin down. All right, the third electron goes in.
2s.
So up. Where's the second electron go?
2s.
Got to go in 2s because it's not full. It goes down. Now, the fifth electron goes in 2p. Now, this is what we were talking about before we left on Tuesday. So you have 3 orbitals that all belong to 2p, right? This is like separate bedrooms. So number 6 goes here. Number 7 takes his own room. But then, is 2p full? No. So number 8 can't go in 3s because this energy level is not what? Not full. So number 8 has to share. Number 9 has to share. Number 10 has to share. Number 11 goes in 3s. Number 12 goes in 3s. 13 gets his own room. 14 gets his own room. 15 gets his own room. 16 has to do what? Has to share. 17 shares. 18 shares. 19 goes in 4s. 20 has to fill it. Now, we're at 20. We need 7 more. 21, 22, 23, 24, 25, 26,
Pardon the interruption, bus 51 just arrived. Please admit those students to class with no penalty.
Questions? Did I have anybody come in on that last bus? I need to mark here, so I didn't get anybody from the last bus announcement. Okay. Questions about cobalt? No? All right, so if we keep going with arsenic, so we're at 27. How many electrons does arsenic have? 33. All right, so if we keep going, we're at 27. All right, do I have enough space for 33 electrons? No. So what do I add after 3D?
4p.
All right, 4p. How many lines above a p? 3, right? All right, so I'm at 27 electrons. What do I do now?
3 more.
3 more. So 28, 29, 30. There's 30. What am I going to do with my remaining 3? Add them to 4p how?
1 in each.
Single arrows. So all of them take their own space, their own room. Questions about arsenic? Are we okay with orbital notation? Yes? Yes? All right, pull them out. Pull your homework out. You had to draw 4 orbital notations, right?
Yeah.
You got them? Fabulous. I want to see. You what? All right, try it. Okay. 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 Iron is the one I get. No, where's that one? Okay. Here's yours. Oh, there it is. Nice. Huh? Don't like it. Okay. All right. Jada's not here. Arena's not here. ABL's not here. Lewis is not here. All right. What this is over here, so I know what to put in Power School when we finally get Power School service again. All right, so 4 orbital notations, and they were lead, Se, Mo, and Al. And this is a stack of crap. All right. So the shortest one to do is aluminum, right? Aluminum had 13 electrons. So you should have 1s, 2s, 2p, 3s, 3p. Because you have how many electrons? 13, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 electrons. Those are half arrows, by the way. Questions about how to do that? Anybody need me to explain how I got the answer? Sailor, since you said you did it wrong, you know what you did wrong?
Yeah.
Okay. Anybody have a question on how to do that? All right, what was the next one? SE?
Yeah.
All right, SE had 34. 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Questions about SE? Everybody good on SE? Okay. Yeah. Okay. Now, MO had what? 42? Yeah. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. Yeah. Questions? Okay, I'm going to cheat on the last one. Instead of starting that all over again, just to save some time, I'm going to do lead from this one. If y'all have a question, just say. Yes, no? Are you getting them right? Do you understand where you went wrong? Questions? Anybody? All right, so lead had 82 electrons. So after 4D, what comes next? 5P, and then 6S. This little tight in space. Let me move that. Move that down here. 4F, 5D, 6P. Okay, so I'm at where? 42, 43, 44, 45, 46, 47, 48. 49, 50, 51, 52, 53, 54, 55, 56. Am I counting right? Yeah, I'm at 56. All right. 57, 58, 59, 60, 61, 62, 63, 65, 66, 67, 68, 69, 70, 80, 81, 82. Yeah, 82. Yes, ma'am.
So you wouldn't go and put one in all of them?
I wouldn't what?
Like go and put a one in all of them? Well, not a one, but an arrow in all of them first. You just go by the number first. Like if I was to go and put the arrow in each of those, all of them, and then go back and start using the number.
I did that. I did that. So when I did my F's, I did 1, 1, 1, 1, 1, 1, and then I did back.
To the same number. I'm talking about the whole thing.
Oh, this was the F's, so I did all of them first, and then I went back. This was the D's, so I did one across those, and then I went back. So I didn't do the whole line because they weren't all the same sublevel. So I only put one across all the F's before I doubled back. And then I went and I did the D's and did one of all the D's, and then I doubled back. Okay, I only put one in each of the sublevels. So I didn't go all the way across the line because they're not all the same. So when I started counting, I just did 1F, 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 1F. Then I went back into the second F, second F, second F, so forth and so on.
So you just do that for each of the sub.
For each sublevel, yes. So if I'd had, let's say, 84 electrons, I would have done 1p, 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 and then I'd have come back and put one more there and stopped if I'd had 84. But since I had 82, I only had enough for 2. Okay? Questions about the homework? Can we draw arrows? Y'all tired of arrows?
Yeah.
Good. Let's learn something shorter. All right. Now that y'all are good and tired of it, let's draw electron configurations. Okay? Electron configurations. How are they different? Okay? Electron configurations only show total electrons in the sublevel. Okay? They only show total electrons in the sublevel. Now, how is this different? If you look here, come on, grab that and in the back here. So, when we looked at this, this showed the energy level, the sublevel, and every individual electron in all the orbitals, right? Every electron, every orbital. This is only going to show the electrons in, you right?
I'm back. I need to sit down in a second.
Okay.
You got about 3 of them. I just need to check in.
Okay, who you want? Are you going to do them individually?
I'm one at a time.
Okay. So, they only show total electrons in the sublevel. Okay? Now, because we're not going to show individual electrons, the nice part about this, there will be no arrows. Okay? There will be no arrows in this. So it's going to cut our work down tremendously because we're not going to show any orbitals and no arrows. Okay? Now, again, you got to be able to count. So, let's say we want to write the electron configuration for, I don't know, let's do scandium. Let's do SC. SC has 21 electrons. Okay? So, if we look at SC, all we have to do is read the chart and then count up the electrons in the sublevel. So, what's the first thing that we would read in our chart? 1s. So, how many electrons can go in an S? And that's what we write. What's the next thing in our chart? How many electrons can go in S? What's the next thing in our chart? How many can go in P? Now, how many electrons have we placed so far out of our 21 before we get carried away? 10. 2 plus 2 plus 6 is 10. Okay? So we've done 10 out of the 21. We're not finished. Go back to the chart. What comes after 2P? How many can go in S? All right. After 3S, 3P. How many can go in P? Okay. Check again to see how close you are to 21. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is, we're getting closer. All right. What comes after 3P? 4S is going to have 2. So 18 plus 2 is how many? 20. We're almost there. All right. After 4S, we have what? 3D. Okay. Now D can hold how many? Can hold 10. But 20 plus 10 puts us at what? 30. We don't want 30. We want how many? We only want 21. So if we have 20 and we want 21, we're going to put 3D how many? We're going to write 3D 1 because 20 plus 1 gives me 21. That's an electron configuration. That's easy, isn't it? No arrows. You're just showing the total electrons in the sublevel. So there'd be how many electrons in the D sublevel? There's how many electrons in the D sublevel? You only have one, okay, in this particular element. All right? So, can we do another one? Can I erase it? Just so the chart's in front of us? All right, so let's say that we do, I don't know, let's do silver. Silver has how many electrons? Okay. So, what's the first thing in our chart? 1s. How many can go in S? All right, what comes next? How many electrons can go in S? All right, next. How many can go in P? Next. How many can go in there? Next. How many can go there? All right, let's stop and count. How many electrons have we placed so far? 2 plus 2 is 4 plus 6 is plus 2 is plus 6 is 18. Everybody see how Chris got 18? Are we at 47? We got to keep going. What comes after 3P? 4S can hold how many? After 4S, we have what? 3D can hold how many? All right. This was 18, so plus 2 is, plus 10 is, we're getting warmer. We're not at 47 yet, so we need to keep going. All right, so after 3D, we have how many? Or what comes next in our chart here, I should say? 4P can have how many? Okay, next. 5S can have, okay, let's count again. So this was 18, plus 2 is, plus 10 is, plus 6 is, plus 2 is, so we're at 38. We're getting a lot closer. All right, so after 5S comes what? 4D. All right, so if I add 4D, 4D can hold how many? Can hold 10. But if we add all 10, 38 plus 10 puts me at what? 48. I don't want to be at 48. I want to be at what? 47. So am I going to write 10 there? No, I'm going to write 4D what? I'm going to write 49 because 38 plus 9 puts me at 47. Does that make sense? Yes? Okay. Think you can do some? All right. I want you to do, let's say, I don't know. Let's do bromine and platinum. No, not platinum. Polonium. Do bromine and polonium. Then we're going to learn how to do dot diagrams. I assume you have no note. You don't have a tardy note or anything? Does it say excused? No? No.
Why do you pick such big?
Do you have a lab sheet, lab report?
Yeah, I was gonna ask, did you pick them up?
Yes, I do. So bring that to me so I can not mark yours later. Ma'am? All right, anybody else come in since I did attendance? Let's get the lab sent. Anybody else still not here? Karina's still not here. Who's nonsense? What's wrong? It turned off. Oh, it's rebooting. Makes complete sense to me. It needs to start in the middle of class. Piece of crap. Yes. I want you lost, you stupid computer. There we go. All right, we're done. Hoping I'll be able to get back with it. Don't. All right, so if we look at your first one, all right, what I assigned. Bromine.
Yeah.
All right. So for bromine, you start at 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. Yes? Okay. What's the next one? Yeah. All right, so you have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p, 1, 2, 3, 4. 6p4?
Yeah.
Okay. Questions? 4f14.
6 people.
And then 5d10. And then 6p4. It's way easy. Yes, it is. I'm going to teach you a shorter way to do it than this. All right.
So if we take like a quiz, can we do it?
Oh, no.
You
The-
said 6P was 6P.
I will tell you what the next quiz is if you want.
The last one was 6P was 6P4.
6p4. The next quiz will be 2 orbital notations, 2 electron configurations, 2 dot diagrams, and 2 shorthands. The only thing you don't know is which elements are which. 2 shorthands. We haven't got a shorthand yet. Or the dot diagrams. Dot diagrams are next.
So that's gonna be all one quiz?
Yes. And we can't take the quiz till we learn how to do all 4.
Okay, cool.
Ah!
It's like 2 weeks tomorrow.
No, we'll hopefully finish it all today. But if we don't, then the quiz will be Tuesday. All right. So, dot diagrams. Dot diagrams require a little bit of notes because you have to learn the parts. Dot diagrams show the least amount of work because dot diagrams only show outer shell electrons. Okay? Dot diagrams only show outer shell electrons. So in order to do dot diagrams, we have to know the difference between inner shell electrons and outer shell electrons. Okay? So, outer shell electrons are the electrons in the highest main energy level. I will tell you it's the one with the biggest coefficient. And I say that because we're going to test next week, and when you're going back looking in your notes, hopefully any of you will, you'll be like, oh, yeah, I remember that word now. Okay? Because sometimes when I say highest main energy level in a question, students go, what's she mean by that? That means outer shell. It's one with the biggest or highest coefficient. Now, the inner shell is much easier to define. It's really kind of a stupid definition. It's basically anything that is not the outer shell. If you're not on the outer shell, you're what? You're the inner shell. Okay? There is only one outer shell. And if you're not it, you are by definition on the inner shell. Okay? Because some rings or elements only have one ring. If you're on that first ring, okay? Catch up with me and I'll draw some. Makes a little more sense in pictures. At least I think it does. I'm a visual person. All right, so everybody got it? So let's say that you have this. How many rings do you have?
One.
That is your outer shell. Okay? But let's say you have this one. That's your outer. That's your inner. But sometimes your models might be much bigger. Okay? You might have one that looks like this. All right? This will be your outer shell. That means all of these right here, all three of these are your inner shells. Okay? So it depends on the size of the atom as to how many inner shells you have. Okay? So in this case, there would be 3 that are on the inner shell and 1 that's the outer shell. Okay? In this smaller one, you got 1 inner and 1 outer. But on this one, you have how many outer shells? 1 outer and there's nothing on the inner. Okay? It depends on the size of the atom. Does that make sense? Okay? So, when I say that the outer shell is that 1 outer main energy level and everything else that's not the outer is automatically the inner shell, you might have 1 inner shell. You could have many inner shells. So, I'm going to write some configurations, and we're going to identify the inner and the outer shell. Everybody got what they need from the pictures? All right. So, if we take some generic examples, like, I don't know, let's just say I write, we did aluminum in our, let's not use our homework. Let's say I write silicon. 1s2, 2s2, 2p6, 3s2, 3p2. Let's say we use iron. We did that one last week. 1s2, 3s2, 3p. Oops, too good to do it right. Let's do. It's up to you. I'm going to use them for examples. I'm going to underline and highlight things. They're your notes. You do what you want. And I would really appreciate you quoting that to fourth period because I swear I only say that to them. When they ask me those same questions. Do we need to write this down? And I tell them, it's your notes. Do what you want.
How much space should we?
You won't need more than a line. Yeah. I don't do this. All right. There's 4 examples to illustrate inner shell and outer shell and how we're going to identify the difference and then to draw the dot diagrams. And I'll give you a minute to catch up. All right, we got it written down? Or do I need to wait? Yes, no, where are we at?
Nothing.
Okay, thank you for answering me. Sometimes I think I just talk to the air. It's what? It is warm in here. It's been cold all week.
I am cold.
You're cold?
I
Yes.
am, okay.
This is the warmest period of the day in here usually. By third and fourth, the air conditioning's usually rolling. So come back third or fourth period tonight, you'll be cooler.
Okay, I'll come back for you.
Bring your peanuts. Popcorn, something. It'll be a circus. All right, we have it now. So if we look at number one, the first one, what's the outer shell? 3p2 is not right.
2p6.
Nope.
1s.
Nope. Y'all got way too many numbers in that in letters.
3.
3 is the answer. Okay? When we said that the outer shell was the what? You go back. The one with the biggest what? Coefficient. You're looking at coefficients. You're not looking at letters. Okay? So when you look at this, you're just examining the coefficients. Where up it? There it is. Then you're just looking at the coefficients. So you have 1, 2, 2, 3, 3. What's the biggest coefficient?
3.
So the outer shell is the 3. This is the outer shell. That means all of this, by default, is the what? That's the inner shell. Okay? Now, when you look at iron, what's the biggest coefficient you see? That means this is the outer, and that means this is inner, and all of this is inner. Now, I picked iron to illustrate that the outer shell may not be where? At the end. Okay? It may turn out to be close to the end, but it may not be at the end. Okay? Now, the other two I picked because they have something in common. What do you notice about bromine?
It's an inner shell between.
That's right. There's an inner shell between them. Okay? So you see the highest outer shell is what? It's a 4. There's one. Whoops. Let me stick with the same color. Okay? It's here and here. Okay? There's your outer shell there. And what's your outer shell in lead? Yep. There's one there, and there's one there. Okay? And in both of those, you will notice that there's inner shells smushed between the outer shells. Okay? In both of those, they're separated between and split between some inner shells. Okay? Does everybody see that? Now, maybe you didn't make it early enough for me to mark you tardy. You're just absent today. All right. So if we look at, oh, and did either of you have the homework, the 4 orbital notations? Because I checked that today. Okay, you want to show me the one for like at least a 25? It's 0. And ABL, do you have it or lab report? No on either of them? Okay. Okay. That's correct. All right. So what are we going to do with this now? Now we're going to draw their dot diagrams. Now, a dot diagram, all right, essentially has an element, and I want you to envision, don't draw this, just follow along. All right, I want you to envision 4 sides around the element, okay? We're never going to draw this box, but I want you to envision 4 sides. The most you can have are 2 dots on either side. So the most dots you can have is how many? 8. Now, if you want to write the most dots you can have is 8, that's fine. Okay? So the symbol of the element goes there, and then the most dots you can have is 8. So let's say we do the first one. The first element we're going to do is silicon. Okay? So Si. Now, its outer shell configuration said 3s2, 3p2. That's its outer shell. All we draw for dots are that. This is all the arrows we're drawing. So this is one reason you had to learn to draw the arrows. So 3s2 had how many lines above it when you drew this yesterday? Okay. And 3p had how many arrows above it? Now, you're drawing how many arrows in the S? How many arrows in the P? 2. How would the 2 arrows look on those 3 individual lines? One on the first one and one on the second one. Yes, you can write that. Now, those arrows you just drew, you have to draw the dots to mimic those arrows. Because these 4 electrons you drew in the outer shell are the 4 arrows that you're going to draw. Okay? That's correct. You're only drawing the dots and the arrows for the outer shell. Because remember, the dot diagram is only the outer shell. We don't care about any of the inner shell. They're irrelevant. Okay? That's why I only boxed in the outer shell and said this is the outer shell. Now, our dots have to look like those arrows. So, when I draw my dots around silicon, I want my dots to look like those arrows. So, these 2 arrows look how? Well, they're paired, is what I want you to tell me. They're paired. So, I can pick any of the 4 sides, but I have to draw the dots as a pair. I can pick the top, the bottom, the side, it doesn't matter, but I have to draw 2 paired arrows or 2 paired dots. These 2 arrows are singles. So I need 2 dots to be singles on 2 of the sides. Doesn't matter which 2 sides. Pick 2 sides, draw 2 single dots. And then I have an empty orbital that has nothing on it, right? So I should have a side that has nothing on it. Now, my dot diagram does not have to look like your dot diagram. You might have drawn your silicon to look like this. 2 dots on this side, a dot here, and a dot here. It's the same dot diagram. You have 2, a single and a single, and a blank side. That's all that matters. Can you have what?
Can you have 3 numbers instead of just 3s2 and then 3p2? Could you have 3?
3 what?
Like 3s2, 3p2, and then like 3s.
No. Because you can't have a 3s and a 3p and another 3s or another s.
Another pair.
Like 4S, 4P, and 4P.
If you had 4s, 4p, and a 4d, are you going to exceed the 8 maximum I just told you you're going to have? Yes. What did I just tell you the maximum number of electrons you can have is? 8. If you get more than 8, you have a what? You have a problem. It's wrong. You did it wrong. You got a mistake. Fix it. You will not get more than 8. Remember, several weeks back, I told you there are very few absolutes in chemistry. This is one of those. You will not have more than what? 8. Will not have more than 8. So if you calculate 9, you get 12. You draw some jacked up example, these crack me up. I use these at lunch with Ms. Bowers and Ms. Thornhill. When people draw these things on the quiz, really, people, if you don't know the answer, guess somewhere between 1 and 8. Anything is better than that. The answer is somewhere between 1 and 8. You cannot have more than 8. So drawing me 22 dots around a symbol, y'all just missed the boat completely. Okay? Do not draw rings of dots, that just spiral around. It doesn't work that way. That's some lunacy there. All right, so if we do the next one. All right, FE, what's the outer shell? Okay, so only a 4S. So FE has a 4S, 2. So how many lines above 4S? How are we going to draw those arrows? Paired. So how am I going to draw my dots? Does it matter what side? Nope. I tend to draw them on top. You certainly do not have to. All right, so if we draw the next one. All right, we have BR, 4S2 and 4P5. All right, so 4S2 and 4P5 for BR. All right, how's the 4S2 going to look? Okay, so 1 line and paired, and 4P has how many lines?
3.
All right, so 1, 2, 3, 4, 5. So, how am I drawing these dots? 3 pairs and 1 single. Doesn't matter which side has the single, as long as you got 3, 3, 3, and a single.
So in order to do that diagram, you have to get the electron configurations. Basically, you gotta know everything.
So basically, this is just too much.
It's just too much, I know. All right, and the last one, lead. 6S2 and 6P. 6S2, 6P2. All right, so what would 6S2 look like? Okay, a pair. And 6S2, 2 singles and an empty. So I would have 2, a 1, and a 1. All right, so for those of you who did your homework last night, we did AL, we did MO, we did SE, and we did PB. We already did PB. Find your homework and draw the dot diagrams for those 3, because you already have your homework. You don't have to do anything. You already drew them. Now, if you didn't do any homework, you got nothing to look at. But if you did your homework, you already have those. So all you have to do is draw the dot diagrams for something you already did. While I hand out a periodic table.
Is this the part that we cut?
Yes. I'm going to call about excluding that water. Learn how to read shorthand. I'm going to teach you my secrets. Because I promise you I don't have that table memorized.
We didn't do anything on that memorized thing.
No.
The weird chart that we use for all this.
Oh, yeah.
What, being able to draw it?
It has the lines.
Yeah.
If you want to be able to use it, you have to have it learned by the time we take the quiz. You just got to be able to draw it.
Wait,
I just bring my.
Yep, so those are like see right through P1.
Yeah.
That's all you need. You got 2 and 1. 2 dots. 1. You already got it done. You're redoing your work. You already got it all.
Is that right?
Yes, that's right. That's perfect. Go Lolly. I know. She hates me and hates the glass. It's all good though. It's okay.
She likes who you are, she doesn't like what you do.
So it's all good. Yes.
Can you teach us?
All right, FE stop. Yes. All right, what's higher? 4x or 3x? You're only keeping this. This is inner shell. You're not counting it. Okay? So your outer shell will only be this. Yes.
So you have
Yes. Almost, yes. The only thing that's wrong here is, see how your 4P is together and then 2 singles? Instead of putting those 2 together, you need to break those up to represent the 2 single errors. Right?
You said they have to be everything.
No,
Just the ones that are.
just the ones that are together. So those single errors have to be single dots. Yeah. That is yes, that is yes. That is no, because you only boxed in that and forgot your 4S somewhere. Right there. Yes. I was wondering how long it would take before it got to you. I'll get it when y'all are calling. Remind me. All right. Does everybody have what they want? Done. So aluminum has 2, whoops, 2 and 1. MO has 2, and SE has 2, 2, a single, and a single. Questions? Yes, no? All right, I'll have you get the colored pencils in a second. Now, I am not giving you forever to color today. So, yeah, but this is not the way we colored last year. I got to figure out where they are up here. This is a different way, Angel. This is based on blocks. We didn't do this in physical science. Oh, I have to bag on periodic tables on here. There they are. Now, this is not meant to be a museum piece. We are not spending 20 minutes coloring this periodic table because we're not, okay? So, now, do not color so dark that you cannot come back and put numbers in. First of all, notice where I put the blue. You do not have to use the same colors either. All right? Now, these 2 groups are blue, as is helium. All right? That's going to be labeled the S block. This middle section from here all the way over to zinc is going to be labeled the D block. This down here is the P block, and the one I'm going to leave white at the bottom down here, these 2 rows will be the F block. Okay? Now, I have colored pencils, and I'm going to set them on the back table where it's a little easier for people to get them so that you're not all trying to kill each other trying to get pencils out of the box. All right, if you need to sharpen them, the pencil sharpener by Chris will allow you to sharpen colored pencils. Only because I have a service plan that will replace it if you break it. All right? I've replaced it once this year already. All right, flip that one. You got 10 minutes to color it. Hey, how are you guys? See, what is it? No. Why didn't you give this here earlier? Oh, you came in late, that's right. Yeah. Why? I'm yours.
It's ugly.
Are you kidding me?
No.
Here.
Thank you. What are you saying? You tell us to look F blank, or we can color that.
Oh, you can color it too. I just used, I left it blank since I only have black left up there. You're welcome. All right, are we done coloring?
No.
Hey, come on. I'm done now.
No.
Well, y'all need to find a way to finish. Come on now.
I found it.
All right, so we want to learn how to read the periodic table so you don't have to rely on that chart that I drew with the arrows, simply because it's a pain in the rumpus. So, some of you are going to get confused with the arrows, or you might just not remember how to do it on exam day. So, let's put some numbers in. I'm going to clear out all this coloring I did so it's easier to see the numbers and just write SP. Right word with this. All right, we're going to write numbers in. I'm going to put these in color. All right. 1, 2, 3, 4, 5, 6, and 7. Okay. I got that? Now, right here in front of the D block, 3, 4, 5, 6.
And they go by like block, not by line, right?
Yep, they go right in front of the block. So this is 3 right in front of SC, 4 is in front of Y, 5 is in front of LA, and 6 is in front of AC. Now, for the P block, some people like to write a 1 up here to go in front of helium. I don't typically write the 1 up there, but some people like to. Boron gets a 2 in front of it. 3, 4, 5, 6. And down here on the F block, we have 4 and 5. Yes, because it's literally right there for the D block.
What if you wrote it inside the block? Yeah.
As long as you know what it means, it's fine. All right, so we want to be able to read the periodic table without having to read that arrow chart. Now, we're going to read the configuration for, let's just say, magnesium. Do not write the examples on this periodic table because you'll just junk up your periodic table. If you're going to write the examples, write them in your notes. All right, I'm going to write them on the board, obviously, because I don't have any other place to write. You write them in your notes. Now, magnesium. When you read this periodic table, you read it just like you read the pages in a book. You start at the top left and you read left to right. When you get to the end of a row, where do you go? Down to the next row, back to the left, and read across again, right? You read the periodic table the exact same way. What is the first number that you read right here? What block is this? What block?
Oh, S.
You write S, so 1S. Anybody lost by how I got that? Everybody good? How? What? What number? What block? That's how I got 1S. Okay? How many elements do I have? 1. We write 2. We're at the end of the row. Where do I go? All right, what number do I have? What block? How many elements do I have? 1, 2. I write 2 there. Have I lost anybody?
How did you get 2?
Huh?
How did you get 2 for
1. That's block. 1, 2. I'm at the end of the row. I come back to the next row. 2, S block, 1, 2. I'm here. Where do I go? Straight across the page. What's the next number I see? What block? How many elements do I have? 1, 2, 3, 4, 5, 6. Am I at magnesium yet? I keep going. I'm at the end of the row. Where do I go? Back over here. What number do I have? 3. And then S. And then 2. I write 2 because magnesium is 1, 2. It's the second element. Are you with me?
So you don't do it like all the ones in S, then all the ones in D, then all the ones in D?
So can we memorize one way with either the other chart?
No, because you'll notice on the other chart, I stayed out of this range and all of this range because the other chart will not read anything I just drew lines on in red. It won't work for those elements. You have to learn to read the periodic table to do anything I just drew those red lines in. Because if you didn't notice a while ago, I said, let's do platinum. And then I said, oh, never mind, let's do polonium. Because I picked something that was in the red line. Yes, ma'am.
Why?
Because it wouldn't work with the arrow chart.
Does it work with Bishop?
Yep.
So
You'd be better off just at least knowing.
let's say,
Well, you may not get an element that's down here on the state test. You may get a short one. And that arrow chart works great for short configurations. It just doesn't work for the long ones. Yes.
say that we have H, whatever that is. right there.
Thallium.
Okay, that.
Yeah.
You have to go through each.
Oh, TH is thorium. TL is thallium. Yeah.
So,
I'm going to teach you shorthand. That's where we're going Monday is shorthand because we're going to run out of time to do shorthand today. Because I don't know about y'all, but I'm tired of starting at 1S. Just tired of starting at 1S all the time. Particularly when you have lead and you have 82 electrons. So, we need to shorten this a tad.
Yeah, that's what I was doing before with this.
Huh? But if you want to do shorthand, we can't do it with the arrow chart. We have to do shorthand with the periodic table. Okay? Shorthand will not work with the arrows. Okay. So, if we do another one, just to make sure we know how to do this. All right. Let's say that we pick, I don't know, let's pick GE. All right. GE is here. All right. What's the first thing we read in this chart? 1S. How many? 2, right? We keep reading. We're here. Where do we go? Here. What number do we have? 2S. How many elements do we have? 2. We keep reading. We're at 2P. How many elements do we have? 6. We keep reading. We have what? 3S. How many? 2. And then 3P6. We keep reading. We're back over here. We have what? 4S2. And that's why we have that letter and number right there. 3 what? 3D. All the way across is 10 if you count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 4P, how many? 4P2. And we're at our element we want when we stop. Okay?
Like 5 million.
Now, questions about how I did that? So how do we do shorthand? Shorthand makes this easier. Okay? Sure, we got 5 minutes. You're not that slow. All right. Shorthand is often referred to as noble gas notation. All right? Because shorthand notation uses the noble gases on the periodic table. Now, when you look at a periodic table, the noble gases are that column, which we'll label on a different periodic table on Monday. And Almaja's not going to tell me she colored it ugly and needs a new one because she's going to do it right the first time. All right. So, all you're going to do is take the noble gas, and then you're going to write the remaining electron configuration. The catch is this has to be the noble gas immediately before your element. Okay, it just has to be the noble gas before your element. It can't be 2 rows before. It has to be the row immediately before. Okay, and then you write the configuration after your element.
When you say rows, you mean left to right?
Mhm.
Columns up and down?
Yeah, so if you're doing like selenium, all right, so if we said we were doing selenium, you would find the noble gas before selenium. So if you looked over here, selenium is here, you need the noble gas before selenium. Well, Kr is after it, so you go up 1 and you get argon. Okay? And we'll work on that Monday. All right? Yes?
Are there any rules for when you have to use it?
No, I'll just tell you to use shorthand. All right, everybody got what they want because I need to write the homework on the board.
No.
You have homework.
No, I don't.
Students get on a birthday.
All right.
Can I just take a picture of it?
What, this?
Yeah.
Yeah. The rate you're going to need to take a picture of your homework.
Can I just write it under my orbital notation?
Sure. All right. So for orbital notation, let's do vanadium and let's do tin. For electron configurations, let's do strontium and iodine. For dot diagrams, let's do tin and iodine.
Okay.
Now, before somebody asks me this, on the quiz, you cannot ask me, Miss Wall, does the orbital notation have arrows? Which one's the dot diagram?
Okay.
I will not tell you that.
Well, can you tell me now? Which one?
Look in your notes.
Wait.
Orbital notation has arrows.
Dots
I know
Dots
that.
have dots. They're
I know
only the
that.
outer shell.
Dots is SN, Z is SR.
Huh?
And which one is on that? Are they both?
Give me a birthday.
You really can't tell that these two are N's and that's an R? I tried to make that very obvious. What?
You really want me to do homework on your birthday?
Your birthday is Sunday and you can do homework today or tomorrow. Your birthday is not for 3 days. Your birthday is Sunday.
I do my birthday. I do my homework on Sunday.
Happy birthday. Do your homework a day early.
Oh, wait.
Yes.